Hey, what's up guys, this is Audie from ShastryNation, and today we're going to be learning about measuring in chemistry. Alright, to start out, let's talk about two things that we want to maintain when we're measuring things in chemistry. Precision and accuracy. To you, those things might seem to be the same, but in chemistry, there's a huge difference between accuracy and precision. Alright, so in order to illustrate the difference, I'm going to use the classic target example. Alright, so precision actually refers to how close the measurements are to each other. Right? So remember, these don't have to be accurate, they just have to be close to one another. Accuracy is different as it's a comparison of how close the measurement is to the accepted measurement. Now with all of that out of the way, let's move on to significant figures or sig figs. The purpose of significant figures or significant digits or sig figs is to maintain the overall value and accuracy of the measurements. For example, you can't say that you have 0.2345601 milliliters of water if your graduated cylinder only measures to the 10th place, because at that point you're just making a very unlikely guess. So overall there are 6 rules to maintain when dealing with sig figs. Rule number 1, all non-zero numbers are significant. So now that we have that rule, what about the zeros? So the rules for zero are that all leading zeros or zeros before the number are insignificant or they're not significant. So for example, in 0.234, the zero is not significant. The second rule regarding zeros is that all zeros in between two non-zero numbers are significant, always. So finally, the last rule is that all zeros after the numbers is only significant if there is a decimal place in the number. Okay, so those rules are all fine and well for numbers, but what about things like pi? Alright, so in general, these are considered to have infinite significance and are usually not a part of any of the calculations. Before I forget, all converted numbers, equalities, and other things like that are also considered to be infinitely significant. Now lastly, let's move on to scientific notation. So the rule for this is pretty easy. All numbers inside the coefficient are generally considered to be significant. Alright, let's try an example. Alright, so how many significant digits are in this number? Pause the video if you need to. Alright, moving on. This number actually has 9 significant digits. So in most cases in chemistry, you'll actually have to compute things with these measurements, and so I'll show you how to carry over the significance and significant figures while doing these calculations. Alright, first we'll start off with multiplying and dividing. There's only one rule here, which is to multiply the number as usual and then round the answer off to the amount of sig figs as the measurement with the fewest. I know that's a mouthful, so let's try an example. So if we were to multiply 3.40 and 2.677, we would get an answer of 9.1018. Alright, now, in order to actually round to the correct significant figures, you have to realize that 3.40 has the least amount of sig figs out of the two numbers that you're multiplying. Alright, so since 3.40 has the lowest, 3 sig figs, we would have to round the answer to 9.10, which is also 3 sig figs. Okay, now we're going to move on to adding and subtracting. So adding and subtracting is pretty easy. All it deals with is the number of decimal places that you have, or the number of digits you have behind the decimal place. So you have to refer to the one with the fewest number of decimal digits behind the decimal, just as you did in multiplication with regards to sig figs. So in an example of 3.14 and 2.333445, 3.14 would have the least amount of decimal places and thus will be used to determine the place being rounded to. Finally, we can move on to uncertainties. Uncertainties are a way to determine the range and precision of your calculations. So for example, you would have a higher uncertainty than a professional lab because your lab equipment is less precise. Alright, so there are a couple of rules when it comes to uncertainties and we'll discuss them now. First off, when measuring, you have two different rule sets. With digital equipment, you add an uncertainty of 1 to the smallest increment. For example, if a scale measured to the 10th of a gram, then your uncertainty would be equal to 1/10 of a gram. The plus or minus indicates the range. With analog equipment, half of the smallest increment is considered as your uncertainty. For example, if a graduated cylinder measured to the 0.1 or the 10th, you would write the uncertainty as 0.05. One thing to remember is uncertainties always take precedence over sig figs. Also remember that uncertainties can only have one sig fig. Now let's move on to adding and subtracting with uncertainties. When adding and subtracting, you just add the absolute uncertainty. The absolute uncertainty is the uncertainty that we've been talking about throughout the video. For multiplying and dividing, you just add the percent uncertainty. You can get the percent uncertainty by dividing the uncertainty over the actual value that the uncertainty is a part of, and then multiplying it by 100. Remember to keep one sig fig. Alright, finally, when averaging the numbers, you actually just keep the most common uncertainty. Earlier I mentioned that the value had to match up with the uncertainty, and by that I mean that the number of digits behind the decimal in the value must be equal to the number of digits behind the decimal in the uncertainty. So in order to have the correct answer, you must actually round to the decimal place that the uncertainty is pointing out. Now remember, you only have to worry about these with absolute uncertainties and not with percent uncertainties, so keep that in mind. Alright, that's all. I hope you guys learned something about measurement in chemistry. The next video will come out in 2 weeks, and I hope to see you guys there. Alright, thanks for watching, and I'll see you guys on the next one.